Let's begin. Today's November 19th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 6, 17, 19, 21, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our middle digit, the square digit, and compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should the value of square be greater than 3? Criteria card B again takes a look at that middle digit, the square digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card C will take a look at our 3-digit solution, and the Turing machine will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2? Maybe even all 3 are even. Criteria card D will take a look at our first 2 digits, triangle and square, add them together, and we'll compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E again takes a look at the 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. The first one is whether the 3-digit code has a pair, as in the example 131, or alternatively has no pair, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F will take a look at our 3-digit solution from triangle to square to circle, and will let us know a little bit about the ordering of the digits. So should the digits appear in an ascending order, meaning that they are increasing, as in the example 135? Should they be in a descending order, or basically decreasing, as in the example 421? Or could the 3-digit code have no order? So let's take a look at the given example of 231. Notice that when it goes from 2 to 3, it increases, but then it goes from 3 to 1 and then decreasing. Of course, you could also have a code that decreases and then increases, but it's basically that shift from one to the other that is one way to define a 3-digit code as having no order. We've also seen in other puzzles where if you have consecutive equal digits, that can also exhibit a 3-digit code as having no order. So for example, if you have a code that's say 334, when it goes from that 3 to the second 3, there is no change. It neither increases nor decreases. So that lack of change is another way to define a 3-digit code as having no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing machine does not approve of my choice for square. I did pick an odd 1, but because the Turing machine does not agree with it, it's letting me know that square should actually be an even digit. So let's go ahead and type that up in our notes for section B. And we'll say that square is an even digit. And since it is even, let's go ahead and cross out all of the odds in square. Okay. Of course, it's interesting to see that criteria card C, the number of evens is present. Of course, there can't be 0 even since we've already established square to be even. And I don't think you could have 3 evens. I think because of the what I stated earlier about the ordering. So remember, since you only have 2 and 4 to pick from, if you have 3 evens, either they're all going to be equal, right? So something like 2, 2, 2, which would be have no order. There's no change among all those 2s. Same thing for all 4s. But if you had 2 of one of a kind, say 2 2s and a single 4, well, as I mentioned earlier, if you have consecutive equal digits, that would exhibit no order. And in case the 4 happens to be between the 2s, there is that change. It increases from 2 to 4, but then decreases 4 to 2. So for that reason, that would make this card, the ordering card, irrelevant, because we would know if you had 3 evens, there'd be no order. So it really boils down to whether there's just a single even or perhaps 2. And I'm trying to decide between that 50-50 and whether there's a pair or not. I'm trying to decide. Let's go ahead and test criteria card C. Okay, so it does not approve of my choice of a single even. Like I stated earlier, it can't be 0 since we do have 1. And we already established square to be even, and you can't have 3 of them. So it's basically saying that, well, I'm deducing that there should actually be 2 evens. So let's go ahead and type that up in our notes for section C, and we'll state that I'm going to deduce that the solution has 2 evens. And now we don't know which of triangle or circle might be that other even, and even less if they are paired up or not. So let's see. So typically if you have 2 evens and they are distinct, it could be that the sum of the first 2 might be 6. That's a possibility. Notice also that there's no mention of circle in any of the other criteria cards. So somehow it's going to be forced into that value, whether it's even or odd. And it may have something to do with either criteria card E or F. And let's see. So, and if the sum is 6, obviously square could let us know which of the 2 evens it might be. And then triangle would be that other even for a sum of 6, if that's the case. So that would leave circle to be odd. So, it could be something like 2, 4, 5 or 4, 2, 1. I'm trying to see. Let's go ahead. You know what? Let's go ahead, because I think if we choose criteria card E, if it's a pair, then we know it's a pair of evens. If there are no pairs, then we know that they'd all be distinct. So I think that would be a better choice than perhaps criteria card D. We'll see how that plays out. Okay, so yeah, let's go ahead and test criteria card E. Okay, so the Turing Machine approves of my choice and my proposal in 314. Notice that they are all distinct. So in fact, there are no pairs. So let's go ahead and type that up in our notes for section E. and we'll say that the solution has no pairs. So they're all distinct. Let's see. No pairs. Yeah. Okay. Well, yeah, I don't think that necessarily helps us cross out anything. So that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we will be discussing how to construct a good second round proposal. So again, we did not test criteria card A, comparing that middle digit, which we now know is even, comparing it to the number 3. We also did not test criteria card D, the sum of the first 2 digits, and comparing that to 6, nor did we test the ordering. So let's see, is there anything we can say about the ordering? Hard to say, but I think we're going to go with the premise of the sum is going to be 6. Let's see. So, yeah, if the sum is going to be 6, again, we're going to have 4, 2, that would mean that circle is odd. But how do you choose between 3 and 5? So I don't think that's going to be the case. So either it's going to be descending, as in the example 4, 2, 1, or it could be that it could be even increasing, as in 2, 4, 5. So those are the 2 likely possibilities. That's if it's equal to 6. Now, what if the sum of the first 2 are not equal to 6? What could that mean? Again, if they're not 6, that would mean that triangle would be the odd value, and it could be something like perhaps 5, 2, 4, where you're wanting, say, a sum that's greater than 6, and if you minimize the square, it sort of forces you to pick 5. And then, of course, it's going to be the other even. Or it could be the other case where maybe the sum is less than 6. Again, if you force square to be 4, then you're obligated to pick 1 for triangle, and it'd be 1, 4, 2. So there are several cases. I'm trying to think what would be best. Perhaps if we stick with sum of 6 and choose the ordering, maybe we could hedge our bets. Square is going to be a 50-50. Is there any way to deduce the ordering? I don't think there's a way we can deduce the ordering. Well, let's go ahead and let's see. Is there a way where if I pick a sum that's less than or greater than, will that help us deduce whether it's 6 or not? They're different. 2, 4. So it seems like if it's a sum of 6, you're forced to either it being increasing or decreasing. If it's a sum that's neither, well, not 6, meaning less than or greater than, you're going to have no order. That almost feels like it's a safer proposition where, you know, if it's increasing or decreasing, you're almost forcing what those digits are. You have no real choice. So I think I'm going to pick 5, 2, 4. And so I'm actually saying that the sum is going to be greater than 6. Let's give that a try. 524. And just to double check, yeah, that middle digit is even. We do have two evens, and they are distinct, as in no pairs. Okay, well, let's give that a try. Okay, so let's go ahead and pick criteria card A, though. I want to see what that middle digit is. Okay, so it does not approve of my choice of 2. Notice that 2 is less than 3. That is incorrect. We also know that it can't be a 3 since it's even. So we're going to deduce that square should be greater than 3. So let's go ahead and type that up in our notes in A. And we'll say that we're going to deduce that square should be greater than 3. And that would mean that, yeah, square is 4. Okay. And I think at this point, let's go ahead and test D, the sum. Okay, wow, so the sum is greater. Now that did work out. Wow, I'm a little surprised. Okay, so let's type that up. So yeah, since my choice for triangle 5 and square 2, that's a sum of 7. 7 is greater than 6, and the Turing machine approves of that. That means that triangle plus square must be greater than 6. Well, that really changes things up. That should be greater than 6. So what does that mean? Well, if we have a 4, obviously triangle can't be a 1, can't be a 2, it could be a 3, but it can't be a 4 because you can't have duplicates, and both 3 and 5 do give you that sum that's greater than 6, which means that circle has to be the even. So that means it's got to be the 2. So let's cross out all the other remaining digits. And so it comes down to either no order or it's decreasing. So let's see again, can we somehow deduce whether it's no order or if it's decreasing? Anything? Nothing really comes to mind. Yeah, because, there may not be a way to deduce it. Okay, well, let's go ahead and test criteria card F. Okay, yeah, so in my proposal 524, it is no order because it goes down, it decreases, but then it increases. So yeah, we'll say that the solution has no order. And since it's supposed to have no order, that means triangle cannot be a 5, because that would mean that it's a descending solution, and we don't want that. So yeah, it looks like 342 is our answer. So let's go ahead and type that up. And let's kind of review that kind of quickly. So is a middle digit greater than 3? It is. It's 4. And of course it's even, yes. There are two evens, there are. The sum of the first two is greater than 6, yeah, it's 7. And there are no pairs, that's correct. And it has no order. Well, that looks like our winner. So let's verify nonetheless that 342 is correct. So 342. Fantastic. Well, how did we do versus a Turing machine? So I believe it was, or it is, a 6 criteria card puzzle, and we did exactly 6 tests. BCE in the first round and the remaining 3 in the second, so we didn't have to duplicate any criteria card. Let's see, we did get the first 2 incorrect in the first round and the first one incorrect in the second round. So that was BCE. Let's type that up. So B and C were incorrect. E was correct. In the second round, A was the only incorrect, and both D and F were correct. So how do we do? Wow, we tied it. Okay, so it was a close decision, but of course a tie means that we did win. Trying to see if there were any inefficiencies or could we have done something a little bit better. Not sure. The only thing, of course, typically, we see a lot of puzzles that have a solution that has no order, but you can't really assume that from puzzle to puzzle. And again, I don't know if I missed a deduction that we could have had in that case. Well, how about you? How did you solve it? What criteria cards did you choose, and did you see anything interesting that you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.